Good morning. This lesson is for my Integrated 1 classes, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of are two goals for the day. Our first goal is going to be to create a formula to write an equation that represents a table. Our second goal is going to be to simplify that equation. So let me just briefly give you an overview of where we're at with this series of lessons. So we've been writing equations that represent tables, and the tables started with an input value of 0, and then they went to 1, and now we can do this process with any number as long as the x values are sequential and the y values are increasing by a constant value. Now in this lesson, we're going to start to recognize, we're going to extend what we ended the last lesson with an observation about numbers we see in the equation and numbers we see in the table. And so we're going to start to streamline the process, which means make it faster to write the equation of the lines. So hopefully you're able to follow along, and I'll just stop rambling so I don't repeat myself, because I don't like repeating myself. So let's jump into our first goal. We're going to recognize numbers that are repeating in the table. I just repeated myself. And in the equation, so they're going to repeat in the table and in the equation. When we create the formula, we will describe their position in the table. Let me read that through one more time without breaks. We're going to recognize numbers that are repeating in the table and in the equation. When we create the formula, we will describe their position in the table. So let's go through the process that we've been doing, and then we'll recognize numbers that are in the equation and in the table, and that's how we're going to create our formula. All right, so first let's see if we have a good table. These are sequential, so that's good for the x values. And my y values are increasing at a rate of 2. So plus 2, and plus 2. So we have a table that we can rewrite with repeating numbers and then write our equation. All right, so let's see here. This is going to become, let's see here. First row stays the same. All the x values stay the same. So how do I write the value of 25 using a 23? Well, it's going to be 23 plus, I need 1, 2, but 1 is not repeating a number with 8, so we're going to get creative how we write the value 1, and we're going to say 8 minus 7. All right, this is still the value 1, and I have my repeating numbers. The next number is going to be 9, and how do I write the value 27 using a 23? Well, it's 23 plus 2 2's. Well, 9 and 2 are not repeating, so we're going to write the value 2 using the number 9, and it's 9 minus 7. And let's get to row 10. And how do I write the value 29 using a 23? I have to add 1, 2, 3 2's. So it's 23 plus 20 plus 23 plus 2 times 3. 3 and 10 are not repeating, but I need to write the value 3 using the number 10. So I'm going to say 10 minus 7. So I have repeating numbers. Everything else is the same. So I can now generalize to x. So x is, let's see, the x row will be 23 plus 2 x minus 7. All right, which means I can now write our equation. And so our equation is going to be f of x equals 23 plus 2x minus 7. Parentheses 2x minus 7. All right. So let's verify this, because I've written my equation and I've written the table with repeating numbers. And let's make sure it works before we look for a pattern. All right, we'll look for, make sure it works. So I'm going to plug in a 9, I should get a 27. And again, you don't have to write what I'm writing, but I'm just reinforcing the way that I show that this works. Plug in 9. Let's keep these problems separate. All right, should get 27, okay. So we get f of 9 equals 23 plus 2, 9 minus 7. 9 minus 7 is going to get me to 2, so 23 plus 2 2's. 2 2's is going to get me to 4. 23 plus 4 is going to get me to 27. So we have a good equation. Alright, so we've gone through the process that we've been working through, and now we're going to streamline. So in the previous video, I started underlining numbers that are repeating in the equation and in the table, and so let's go ahead and do that again. So we'll go through the original equation. 23, where do I see 23? That's the first y value. 23 is the first y value. Remember, f of x is a funny way to say y. Alright, so I got a repeating number there. 2. Maybe I should use a different color. 2. Oh, not the same color. Oh, you can do this. Alright, still early. So where do I see 2 in the table? That's the number that our y values are changing by. Alright, and we've got one more number that we need to recognize and highlight. And I haven't used purple yet. Alright, 7. Where do I see a 7 in this table? I see a 7 here, but the thing is, it's the opposite sign. Alright, so I'm going to now describe these numbers and create our formula and then finishing our first goal. So remember, when we create the formula, we will describe their position in the table. So here's our formula that we're going to use. And I'm sorry that I'm writing it down here, but I'm running out of room. So f of x equals the first y value. I'm going to say f of x. First f of x value plus the change in y parentheses. Now this always is an x plus. Now 7 is the negative 7 is the opposite of the first x. So plus the opposite of first x value. And again, I apologize for writing this down low. I'm trying to do this in one take. And so I'm realizing it's a little bit crowded, but I'm not filming it again. Alright, so this is our formula, and we have another example here that I would like to write the equation of our table using the formula and verify. So we're going to streamline that case. We don't have to do this anymore. But we need to make sure that our x values are sequential and our y values are repeating by the same amount. So the x values are sequential, so those are good. And let's see how our y values are changing. They're changing by subtracting 4. So this table satisfies what we need to write the equation. Alright, so let's see here. Let's go through the steps. So it's going to be f of x equals my first f of x value, which is 17, right? First f of x value, so it's 17. Plus our change in y. So this is going to be plus a negative 4, because that's our change in y. Parentheses, x plus the opposite of the first x value. Our first x value is 10, so the opposite of 10 is going to be negative 10. So this is the formula for our equation. Let's verify this now. If I plug in 11, I should get 13. Okay, so we're going to plug in 11, so f of 11 equals 17. I'm going to make this now minus 4. And my x now becomes 11, and that's minus 10. 11 minus 10 gets me to 1. So now I have 17 minus 4. Negative 4 and 1 gets me to negative 4. 17 minus 4, that gets me to 13. So when I plugged in 11, I got 13. Our formula works. Wonderful. So we're now done with the first step. And again, this is our formula. This is what we're going to be using now. It's going to streamline the process. We were working towards this in this whole chapter. All right, our second goal. Let's use our 6 steps to simplify the equations that we verified. All right, So this is kind of an easy process. It's not going to take too long. Let's do our equation from the first example, which is f of x equals 23 plus 2 parentheses x minus 7. All right, let me double check and make sure I'm still on this whiteboard. I hate having to refilm these things because I'm not. Oh, I got plenty of room. Okay. All right, so we're going to use our 6 steps to verify, or not verify, to simplify. Do I have fractions? No. Can I distribute? Yes. So now we get f of x equals 23 plus 2x. Positive 2 and negative 7 gets me to minus 14. All right. Can I combine like terms? Yes, I can. 23 minus 14 is going to take us to, oh no, I have to do some math here, that's 9. So now we're going to get f of x is equal to 2x plus 9. So that is going to be the simplified version of our first equation. All right, let's simplify this second equation here. And again, we'll just use our 6 steps. Let me give myself a little bit more room. So we have f of x equals 17. I'm going to make this now minus 4 parentheses x minus 10. Now, we don't have to go beyond step 3 most of the time. We'll see in the next chapter we have to use step 6, but right now we stop there. All right, so again, we're going to go through our 6 steps that we know. Can I get rid of a fraction? No, I cannot. Can I distribute? Yes, I can. So now we're going to get f of x equals 17. Negative 4 and x gets me to minus 4x. Negative 4 and negative 10, that gets me to positive 40. So I distributed. The next step is, can I combine like terms? Yes, I can. 17 and 40 are like terms. So here I can say I get f of x equals negative 4x, because nothing happened to that, and 17 and 40 gets me to 57. I have now simplified my equation. All right. So this is what simplifying the equation looks like for us right now. It's just step 2 and step 3. All right, let me double check and make sure I'm still on here. Okay, good. All right, so I'm going to go ahead and end this lesson here that showed us how we created our formula and how to simplify. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.